An algorithms question. We have been given this particular array and they are asking which of the following sorting algorithms will use the least number of comparisons for sorting the given array. So we have been given these 4 sorting algorithms and this is the array which has to be sorted using these algorithms, and how to determine that which of them will use the least number of comparisons. So as we can see, this array is already sorted. So in this case, when an array is already sorted, these algorithms will behave in a different way. Let us see for everyone. The first selection sort, what it will do, if the array is already sorted, it will give the worst performance. In the first pass, it will make n-1 comparisons. Then in second pass, it will make n-2 comparisons and so on. So the total number of comparisons would be order of n plus 1 by 2 kind of thing, and this is just equivalent to order of n square, which is also its time complexity, because in the sorting algorithms we determine their time complexity based upon the number of comparisons that they use. So for selection sort, we can say its time complexity or its number of comparisons is of the order of n squared. So that is definitely not the least, because other algorithms may perform in a better way. Let's see how. Then coming to this merge sort, it does not care if the given input is sorted or unsorted. So for that, it will not matter if the array is already sorted. It will still take n log n number of comparisons, and that would be its complexity as well. So for merge sort, the order of comparisons is always n log n, however the input is, given that its size is n. Finally, coming to insertion sort, now this will give a better performance if the array is sorted, because let us take this example 23, 32, 45. Let's say there are just 3 elements. So what insertion sort actually does, it will pick up an element and it will check if the left part of it, let's say we're at currently 32, it will check left part is already sorted. So what insertion sort basically does, it finds out a correct place for an element and goes and places it there. If we get the next element as say 30, then what it will do, it will check this left half which is already sorted and it will see that this is the correct position for 30. So it will go and insert 30 over there. So 23, 30, 32, 45. This is how insertion sort works. This array is already sorted. It will not need to do any such insertions over there. So it will simply keep checking if there is any violation. 23, 32, 45. If it finds a violation, then it will go and find the correct place for that. But it will not find any. There will simply be n-1 comparisons, and it will reach the end of the array, concluding that it is already sorted. There is no need to perform any swaps. So this insertion sort, it will take order of n comparisons and 0 swaps. So till now this gives the best performance. Its complexity as well as the number of comparisons involved are both linear, that is order of n. Then coming to the last, that is quick sort with last element taken as the pivot. Now there are different strategies in quick sort. We can use the first element or the last element as the pivot, or we can go for the median as the pivot. In case the input is already sorted, then the first element and the last element taken as the pivot will give the worst performance. They will give order of n squared comparisons, whereas if we had gone for median or something else, then we would have reached the best case or the average case complexity or the number of comparisons in quick sort equal to order of n log n. But because we are taking the last element as the pivot, then it will give n square only for the sorted array. So again, this one gives order of n square comparisons. So which of the following is giving the least number of comparisons? That is the insertion sort algorithm. Its complexity as well as the number of comparisons required is linear, order of n, and it will involve 0 swaps for the already sorted input. So for this, the third one, that is insertion sort, will be true.